Hey everyone, thank you so much for watching the 67th Weaviate Podcast with David Garnitz, the creator of VectorFlow. Really quick before diving into it, I wanted to thank David for joining the podcast, and please show some love to VectorFlow on GitHub. Leave it a star if you don't mind. Open sourcing is always awesome, and there are so many exciting ideas in the space of, at the highest level, how do we get data into vector databases like Weaviate? Say you take, text, for example. Text has all these things like, how are you going to chunk the text? Metadata extraction being an interesting topic. Then doing the embedding model inference. And then, with Weaviate, we've explored things like the Spark connectors or gRPC APIs. Just, like how do you get the vectors then into the vector database? And so I had so much fun with this conversation. I hope that, you enjoy listening to the podcast, and please check out the open source GitHub repository linked in the description of this video, dgarnitz/VectorFlow. Hey everyone, thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome David Garnitz, the founder of VectorFlow. This is a super exciting new company that's looking at innovating on how data gets into vector databases like Weaviate, the whole importing data ingestion. So we have so many exciting topics. There's such an end-to-end stack with this. Firstly, David, thank you so much for joining the podcast.
Yeah, thank you so much for having me. Excited to be here.
So could we kick this off with, what inspired you to create VectorFlow, and sort of how do you see the problems in the space?
Yeah, so that's a good question. So to just rewind a little bit on my background, I was a machine learning researcher in grad school, and I worked on some developer tools and infrastructure at companies like SpaceX and Affirm, and ended up going to work for a pretty early stage AI company called FileRead. And at FileRead, we actually had to build a massively parallelized vector embedding pipeline because of the volume of data we were ingesting. And so I saw that pain point with the team there and realized that there wasn't really any good solution in the market, and decided to go off and build it myself.
Yeah, amazing. I remember talking to you earlier about load testing and that kind of thing. And yeah, it's definitely something we see at Weaviate is people who put just a crazy large amount of vectors into it. And, whether it's, billions of vectors and this kind of thing. Can you maybe talk a little more about, just how you see the opportunity with, using vector databases with billions of vectors? I think there's kind of two sides of this. You could be, someone who's hacking on your personal note-taking app, and you probably you probably have 100,000 or so, or you're looking at these big enterprise cases where you have just enormous amounts of data.
Yeah, absolutely. So, I mean, we personally think at VectorFlow that these systems, these retrieval systems, are going to be ubiquitous, right? Because every large company has an incredible volume of data that they can leverage, both for external customer-facing products, but also internal products to save money and move faster. But obviously, the space is young, and a lot of the technologies need to mature, and so there's a big challenge there in terms of ingesting data at scale, putting it in the store, but also understanding which data is relevant. So there's a lot of old kind of stale data internally at these large organizations too. So you have not just a challenge around getting that in, but figuring out which data to draw from.
Yeah, definitely. I think maybe if I could, this kind of old stale data, there are so many components to the data importing into vector databases kind of conversation. I like this, maybe the LLM knows which class. So maybe people who are watching this podcast probably already know that Weaviate uses the class abstraction to kind of isolate some type of data. You'd have one vector index per class. So I like this idea that LLMs maybe know which class to put data in. If you're importing from multiple sources, a common thing that people are building is chat with your documentation, where you might be importing from GitHub, YouTube, say Slack, and maybe you route these to different classes as well. So that kind of, I see that as one thing, as well as the, the stale data kind of refreshes, handling document updates as being another kind of part of this. But so with our podcast, I think it would be really nice if we could just kind of come to an agreement on this end-to-end, what data importing looks like. So I think there's kind of connecting to sources is one thing, PDFs, Notion readers, Google Drive readers. Then there's kind of I see this kind of cluster of things where there's text chunking strategies. There is a lot of kind of naive text splitters, just rolling window chunking, stuff like this. There's also maybe using LLMs that a language model would look at a text chunk and be prompted please split this up where you see semantic gaps, and then it would do the chunking that way. There's also kind of like this metadata extraction. So it's kind of like that layer. And then I see once you have the chunks, you now pass this to the model inference to turn it into a vector. And there's certainly a lot of innovation there. And then I guess finally the last leg of the mile is I don't know if that's a phrase, but is then plugging in those vectors into Weaviate. So is that kind of like a good storytelling of kind of like the end to end what it takes to import data into vector databases?
Yeah, I mean, I think that's a good high level story. I think one thing that we've also encountered in our research and discussions with people, and one of the things that we're looking at actively building into VectorFlow is also this idea of like pre-processing the data before you turn it into vectors. So not just metadata. Like metadata, I think is it's useful for different kinds of hybrid search, right? But there's trade-offs associated with using metadata, like it can make the upload speed slower, or maybe you have to use like a different retrieval algorithm. So what we've heard some people do is to actually pre-process the data to put relevant information into the chunks for even uploading it to the vector DB or before adding any metadata or anything like that. So that's another stage that I think is kind of emerging. It's pretty immature. Curious to see though, or hear like on the Weaviate side, like what are y'all kind of encountering in terms of like usage of metadata and pre-processing and things like that?
Yeah, well, I think this is such an interesting topic that kind of take the metadata out to put it into the chunks, that to just kind of build on that a little bit more. I see that as like, if you're parsing like a legal contract and it's like, clause S3001, and then you would take that header and you would kind of put that into the text chunk, like, this is a part of this clause. And then you hope that that vector embedding is going to be better. It's also probably going to be better for the BM25 scoring when you're then saying, I don't remember the number, like S3001, something like that. Like that kind of adding metadata into the chunk for kind of vector search. But there's a few other ways of looking at this. And I guess another idea, like what I like a lot and what I think is kind of underrated is, let's say I'm parsing out Wikipedia pages of NBA basketball players, right? And I come across like age, like, Jimmy Butler is 28 years old. I don't know how old Jimmy Butler is, but like, let's say he is 28. So like I would take that out and put that as metadata. So then if I want to ask a question like, it could be the semantic search kind of question where I have like a video of someone playing basketball and I'm like, who does this guy play like who is older than 32? Just a random question. Or it could be like an SQL style query where I say, what is the average age of players on the Heat? So it's like, I see this kind of metadata extraction thing as being quite important. I had a bit of a disagreement with Nils Reimers on a podcast where he was thinking that all this metadata can be kind of captured in the embedding and this kind of thinking. And, so let me just pass it back to you to get kind of what you think of this kind of metadata extraction from text chunks.
Yeah, it's certainly an interesting approach. I mean, so I think the thing that we're trying to understand is like, how do you differentiate between putting things like, say, at the end of the chunks, right? So you talked about age, like you could literally just put the age of, say, Jimmy Butler at the end of every chunk about Jimmy Butler, right? But then are you routing the chunk? I think the benefit, right, is that like you can use a more standard kind of like ANN algorithm to retrieve the vectors, and then you can maybe have your re-ranking pipeline or whatever to kind of like get a high fidelity result. Whereas like with the hybrid search, you have to potentially implement something slower, or you need to store the data in a different type of graph or something, right? So there's different trade-offs. But what we're hearing is that in either scenario, these things are really important to improve the fidelity of the results. And that's kind of like the broader theme, I feel like, that we're encountering. I'm curious to hear if you guys are hearing the same thing. But for us, it's a lot of like, we like the systems, they're good, like they're easy to use, but how do we get the results as good as possible? And so that's where we've been trying to understand where in the industry are the best practices solidifying, because it's still such a nascent field.
I agree 100% with that. I think evaluation is nascent, absolutely. Evaluating how well your search is performing, I feel like is more of an academic exercise and something you see. I do think it's picking up though, especially just yesterday we hosted a workshop with Arise AI, and Arise AI, they're building like a visualization observability tool. And so you kind of inspect like, the vector spaces of the nearest neighbors to your prompts and sort of starting to get some evaluation metrics. Like we could definitely dive into this thing about evaluation. That's another one of these major rabbit holes. But but coming back to the data ingestion kind of topic. So yeah, metadata, and I think we can definitely come back to that if we want to. But I really want to talk more about kind of like vectorization. Like once you have the chunks, and now you're trying to like manage inference of like 100 million, I don't know, just a random amount of vectors, but like of text chunks, and you're trying to vectorize them all and get them into, or just get the vectors to Weaviate to then do the Weaviate's half of the indexing part. How do you see that space of like, how can we vectorize this as quickly as possible?
Yeah, I mean, I think that's where a lot of infrastructure comes in, right? Where like you really need to build out a massively parallelized pipeline. And that's kind of where we come into play, where we enable pretty massive scalability as well as configurability leading up to what actually gets vectorized or embedded. But you need to spin up like a message queue, or you need to stream something in from an S3 bucket, and you need not just to be able to do the calculations in a way that's quick and efficient, but also cost effective. But you also need to make sure that you're not dropping anything, that you have a retry mechanism built in. And I think that's where you get into some of these engineering challenges. And this is where like, my work at SpaceX and Affirm is kind of helpful in understanding kind of how to build out this infrastructure. And it's part of why we took the approach that we took at VectorFlow, where we said, well, we're going to be more of an infrastructure first product. So if you look at, if anyone goes to our open source repo, they'll see, Docker images to spin up, a message queue and a database, and making sure that you can get all the information you need to in the database or in the vector database. I think one of the challenges that people don't realize is an issue until they start to operate at scale. I'm actually curious what you guys are hearing in terms of like something that we hear people say a lot in discussions is, yeah, we thought this would be super easy when we were playing around with it, and then we have a follow-up conversation with someone 2 or 4 weeks later, and they're like, oh, when we actually tried to turn it on to production, we realized like, oh, we didn't think through a lot of things.
Yeah, well, I guess for me, it's like using the OpenAI or Cohere embeddings APIs. I think that tends to work for most people. Like they really enjoy just kind of sending their text to the APIs, getting the vectors back. And however, like batching is handled within OpenAI or Cohere is however that's handled. But yeah, I do think once you then are trying to like, you've maybe fine-tuned a sentence transformers model, or you just want to deploy one of the models from Hugging Face's sentence transformers just to try to save cost. Now you open up a huge can of worms of potential like problems to solve. Like you now become interested in like, the whole inference acceleration camp with things like the Onyx runtime, or maybe all the stuff Neural Magic is doing with like sparsity, quantization of weights, just so much stuff there. And as well as kind of like the load balancing between, different vectorization endpoints you might have, as well as maybe you're dealing with like ray actors and you're using GPUs for these inferences. And so now you've added like another layer to thinking about this. So yeah, maybe, so it sounds like to me, like you're maybe more interested in that kind of latter half of, you have some kind of vectorization model. Let's unpack the box and let's try to optimize all these parts of it.
Yeah, absolutely. And I think, so what we've heard is that when you really want high fidelity results, you actually do need to use open source models, because there's a lot more innovation happening in that space specifically for embeddings. Like I think for the large language models themselves, the closed source actors are still probably, in terms of usability, probably the best products. But I know from customer conversations, I know from my work experience at FileRead, that those open source embeddings models actually do, especially for certain use cases, give you really high fidelity. And when you are talking about moving a system to production, really getting kind of the promised productivity gains and things like that, you want to do every single thing you can to make the results better, which is, why you're tweaking different steps along the pipeline, right? So we talked about metadata extraction and chunking. And this is another piece where like you can take your open source model, you can fine tune it, to continue to improve the results. It's definitely challenging though to use them in certain ways. Like some of them are really big, right? Like I think it's like the instructor XXL or something. You need like 24 gigabytes of VRAM, or like just not that many machines out there that can do that, that are
Mm.
cost effective. So you run into these different infrastructure bottlenecks. But I think we're going to continue to see that become more of a norm.
Yeah, I'm really curious about. I guess one question I have is like we just released our like text to vec GPT for all, where it's using the GGML acceleration. Like there's like Llama C++. I'm sure everyone's aware of running LLMs on on like CPUs with C++ and stuff. And so I'm kind of curious, like, is like what is the state of that? Like, can you really run it on a CPU instead of a GPU? Yeah, that's kind of one thing. I mean, I don't know if it would be worthwhile diving too into it. I think the topic that you brought up that would be more interesting to talk further about would be that that fine tuning your open source embedding model kind of thing. I know Gina AI, they're doing some awesome work with their fine tuner, and I'm just curious, like, what you're seeing on how common is it to fine tune an open source text vectorization model, or any image vectorization, any kind of model.
I don't think it's that common yet. Like we've talked to a handful of people that have done it, and the theme that we've heard is like the complexity is actually more than you would think. Because like I
Mm-hmm.
think from what I can tell, fine tuning an OpenAI model is not super hard because they have kind of a nice interface for it. They have like a Jupyter notebook out. But I think when you want to work with an open source model, it's more challenging in certain ways.
Mm-hmm.
I think also it's not totally clear yet what levers to pull in the space in terms of like what's actually going to make your results better. So I think I read that with fine tuning, you need 10 instances of something in the data for it to actually kind of appear in the model weights. And
Hmm.
so if you don't really have well curated data to fine tune on, then it's not going to have that big of an impact. Whereas like, altering the chunks or the metadata could potentially have like a way more outsized impact on your search results. I think another theme in general, though, that is just evaluating, right? How do you actually even, you know, figure out what search results are good or bad for your data and your system? I think is a general challenge.
Yeah, well, I think what's so exciting about I've talked about this all the time because I love this topic, which is like you can use the language model to generate synthetic queries for your documents, and then use that as jointly you could use it as your fine tuning data for embeddings, or you could train like a ranking model where the ranking models are like classifiers that take in query and document as candidate, and it's slower but it's higher precision. Or you could use that kind of data set to evaluate different embedding models. Like now you have a synthetic test set, so you can say, okay, OpenAI, Cohere, sentence transformers compete for my favor, and you could do that kind of thing. So yeah, what do you think about that kind of LLMs to generate synthetic queries to measure search performance?
I mean, I think it's definitely an interesting idea. I've also like played around with this myself. Like I also like in more traditional machine learning tasks have played around with using LLMs to label data, basically generate synthetic labeled data. I think
Mm-hmm.
where you run into a little bit of a question mark in my view is that like no two kind of production grade data sets have the exact same statistical qualities. And so how do you know that something is good for your data set if you're using an LLM to generate something synthetic? Because also like LLMs, I mean, depending on the settings, right, they're inherently stochastic. And so like you're not necessarily always going to get the same results in and out. So I sort of feel like to really start to get something that's meaningful in terms of a test result, you also have to run things through an LLM a lot. I'm
Mm-hmm.
curious to hear what you think of this idea. Like one of the things that we've talked about with people is if you know your data well, you can actually, rather than use the LLM to come up with the questions, you can come up with your own questions and have stuff as a yes or no
Mm-hmm.
answer. You could use the LLM to grade it, or you could grade it yourself. And then you have a pipeline and you run stuff through the pipeline a bunch of times to kind of cover that stochastic variability. And so, like, let's say you have 20 questions and it's like yes or
Mm-hmm.
no, or the right or wrong. You can have a score out of 20 or convert it to 100, right? And then you can do that like 10 or however many times, and you can kind of you have an average and you have a variance, And all you do is you just toggle one variable for each test, and then you can really isolate for my data how effective is tweaking the top, K and top K results, for example, or swapping the embedding model, or changing the filtering mechanism on the metadata. That's how we've kind of thought about it. But I'm curious, because you're so deep in the space too. Like, maybe you have a totally different approach.
Well, I agree completely. I mean, it's like the large language models just kind of like erased the favor, like the popularity of like extractive question answering models, where it classifies the answer in the retrieved context, so there's like no chance of hallucination with that setup. Or just having the search route you to frequently asked questions, and then it's like the embedding similarity of the new question with the embedding of the frequently asked question. And then Neva had published this awesome blog post about like question to question embedding similarity is a lot easier than question to answer, because of kind of like the style. And I think there's a lot of interesting things to that kind of component for sure. And yeah, it's like I mean, there's so much innovation happening on like what the search box looks like. Like, I think by the time we publish this podcast, I don't know if I should say this, because then I like have to have the podcast published after this. But let me just not say it. So, like, there is a project in development at Weaviate that's like, building those UI components for the search box with the site sources and like, the UI for it. There's like, a lot of collaborations happening with like Vercel and Replit. I'm personally not involved in this, but I'm watching this of like, trying to make it easy for people to like plug in front end components. And there's so much like, whether you're using extractive QA or whether you're putting it to a large language model, like how you do the user interface is definitely a big opportunity. Like how we're talking about VectorFlow and ingesting data being a new market category. Developing these kind of like front end components, like if you have like a library of React components, that's also a pretty nice little, as everything is developing further.
Yeah, one of the things I was going to say, we're actually noticing the same thing too, where it's like with VectorFlow, we're even trying to understand what is the entry point to the system. For example, like we started out with an API as the entry point to the system, because that's it's technology agnostic, right? VectorFlow is designed to be cloud agnostic too, but we're also seeing like if you want to rapidly test and you want to iterate, like you probably do just want a UI to configure stuff, and so I think that's in some ways a sign of the maturing of the space, where like it started out right with a lot of people that are research scientists, data scientists, traditional software engineers, and now it's, as it matures and it enters the mainstream, we have to start moving to thinking more about usability and approachability for the average person to kind of get the most out of these systems, understandability. So I think there's a lot of opportunities in that. Um, you know, VectorFlow is really useful for running rapid testing cycles. I think the whole industry collectively still has a lot of work to do around understandability. Why do you have the results that you have? And kind of having tracer. I think they call it tracer bullets, right, in software engineering. Like ways to understand what pathway to the answer did it take. How can I repeat this? And yeah, things like that.
Yeah, no, I agree 100% with that. Like the ability of the zero shot models to evangelize building with deep learning tools for like software engineers has just been probably one of the biggest themes in the story of Weaviate, in my view, is like being able to just take the OpenAI embeddings and then you can build a semantic search application without needing to have the slightest idea in the world about how you would fine tune an embeddings model, which I think is quite a difficult task. And so this is kind of like I'm doing like a long range reference back to the metadata extraction and kind of chunking with L. I really want to kind of get like this kind of importing data into vector databases. I think the interesting thing is I think there's even more opportunity for zero shot models to be plugged into this workflow. And particularly, I'm curious what you think about the idea of like an LLM that's been trained zero. So obviously, like GPT-4 could probably do this task of where you give it that Wikipedia passage of Jimmy Butler and you say, hey, what kind of like symbolic metadata attributes are contained in this passage that you might want to extract? And we go, oh, age 28, let me take that one out. Or this kind of idea of you give it like some messy chunk of text and you say, where do you think you should split this text, as another kind of thing that an LLM could do. One kind of idea is that they're going to fine tune or specialize LLMs that are maybe only like 15 billion parameters. Like 15 billion parameters is, I think, the current state of the art in text to SQL, like zero shot. So fine tuning LLMs to plug them into kind of that part of the data importing stack.
Yeah. So I think, if you think about higher level, like what kind of chunks do you want to help with the search result, right? And so like there's different types. There are chunks that have like relevant information in them. There are also chunks where like, is it keywords in the chunks? Is it the whole kind of
Mm.
semantic idea of like this is a sentence or this is a paragraph, right? And then there's things that are more complicated. So for example, like I'm sure you've heard people talk about summary chunking and how like you want to do summarizing, and it's like you get into some questions about like what are you summarizing? Are you summarizing a paragraph, a page, a document? Do you need to be smart enough to understand like, oh, this is, section 2, part 4, and so you want to like however many pages or paragraphs that is, you want to summarize that. And I think that's where LLMs, especially ones with decent sized context windows, could be really good. I think that the trick is like ChatGPT, especially GPT-4 can be expensive. Sometimes the API goes down, things like that. So if you have like a model that's specifically designed to do summarizing, zero shot summarizing, then that could be a really useful thing to insert into the flow. Likewise with kind of extraction, right? Like you could have a model that's just trained specifically for that. And use that to sort of like extract keywords or extract themes. I think for us, one of the things that we're exploring that is kind of interesting is like, can you actually approach the performance of a deep learning model with something more traditional that's way faster and way cheaper? So, for example, like could you use XGBoost to do sentiment classification and just put those sentiments in the metadata, or and that would be like substantially faster and cheaper. Maybe it's not, the performance is not quite as high as an LLM, but you get other benefits from that approach that allow you to make that trade off.
Yeah, I see kind of two things, like this summary chunking, and let's maybe come back to that. I want to stay on this XGBoost for sentiment classification. This is what Nils took apart with my argument on metadata extraction that I think is extremely, I think it's bulletproof. Is like, if you're letting the LLM just arbitrarily decide what metadata to extract from each chunk, then how do you then query it? Whereas alternatively, if you have some kind of classifier that takes let's say you've trained, just like, I don't know if this is the best example, but you've trained a classifier that takes in Wikipedia passages of NBA players and then classifies the age if it's mentioned, or maybe the team they're on. I don't know. So, or like maybe like how many seasons they've played, if that's maybe something that's kind of ambiguous that you would need to kind of derive from the text, something like that, right? Because if you train a classifier on one special kind of metadata attribute, it's just so much easier to then interface it at query time, because that, like, hey, there are this many age values or teams. I don't know maybe we should have started with a better example of like a metadata to ground this, like, or sentiment. Why don't we just come back to sentiment? Like, so then, at query time, you're giving it a movie review. You want to find the most similar positive movie review, right? Because you have this kind of label on it. Yeah. Yeah. Hopefully that kind of set the transition nicely. Like, what do you think about that kind of, or just to keep kind of giving our thoughts on like this kind of idea of having a specialized classifier for the particular kind of metadata you want to label each of your chunks with?
I mean, I think that's just like a kind of a broader trade-off that you have to think about making with any use of a large language model versus a bespoke machine learning system. Like at File Read, we looked at using different technologies to parse PDFs, and ended up building our own classifier because like we had very specific needs in order to be able to understand the documents. And I think it's all about understanding the data, right? And so like you're using metadata as kind of a way to understand the data and then add additional reference information to make the search better. And so some part of it comes down to the engineering requirements and the business requirements around like cost. Like, do you have time to train a custom classifier? Is it easier in terms of the developer workflow to just use an LLM? Or if there are these off the shelf ones, like, do they easily fit into the workflow? I think I'm curious to hear your point on this, but one of the things that we're observing in our discussions is people are using metadata in really different ways. Like it's not yet super clear like what fields are common and what things we want to put into metadata. So like I think to answer your broader question, that approach sounds like it would work better, right? Because I think for any specific machine learning task, you probably could train a model that could beat an LLM at doing something very specific. It just is a question of like, is that specificity what is needed in the market?
Mm. I guess it's like if I'm imagining I'm building a chat bot or search engine for like Weaviate questions, I might want to classify them into questions about importing data, questions about the query APIs, questions about like replication, scalability, like cloud management stuff. So I might have these kind of categories that I would put on the chunk. But like what Nils was saying that I kind of agree with is like if you have some label that you can classify from the content alone, you can probably capture it in the embedding as well. Like the embedding model could capture that kind of thing in its representation. And that's kind of what I see. Yeah. I guess for me, the reason I like this whole argument is because I like thinking about these systems as like I like to try to point people to the Weaviate's aggregate API. Like Weaviate, it's a vector database, but you also can do symbolic queries in Weaviate. Like if you want to say what's the average age of NBA players, you can ask that kind of question to Weaviate. So that's kind of what I see as the clear value of the metadata. For kind of query parsing and adding filters to queries, I'm not sure I understand it all the way. I understand definitely, like, as one of our earlier conversation topics, like a part I imagine with the end-to-end importing data to Weaviate is like you import it from multiple sources. Like you have tweets, you have GitHub, you have YouTube, you have Slack. And so you might want to put those into like, you might want to have a symbolic filter that, separates that at query time.
Yeah, I mean, I think the space is so young, right? That I think one of the things we're going to see emerge is sort of more standardized access patterns, let's call them, right? And I think that's one of the kind of visions for what we're trying to achieve with VectorFlow is to be part of this process of like almost building like an HTTP for kind of querying your semantic, your contextual data, right? So like not HTTP itself, but this idea of a protocol, standardized fields and things that you're going to access. So as the space matures, we might understand like these are the types of metadata that are really important
Mm.
and that most people use. And then it does make sense to have off the shelf classifiers to do those things, to extract those things.
Yeah, because, yeah. Yeah, well, let me get your temperature on that argument of if you can classify it in the content, the embedding can also capture it.
Yeah, I mean that makes sense, high level.
I guess like for me, it's like the vectors are so entangled, like a vector representation of an object, like from OpenAI, the 1,536 dimensions. You can't like point at two indexes of that vector and say this is how much of a cat it is, right? Like it's completely entangled across the entire vector. So that's why I still see like if you classify, like you have a picture of a dog and like yeah, the embedding captures that it's a dog, but if you have a classifier that does the like it might be a dog jumping to catch a frisbee or it's like in a pool or something, and so it's kind of like entangled with like dog but also like dog swimming kind of like so I see if you have some kind of attribute that you know is going to be super important, like what kind of particular dog it is, to classify that and have that in addition to the embedding, I could see that as being some kind of lever that could improve your search relevance.
Yeah, absolutely. I think we're agreed on that. I think one of the things that I'm curious about, maybe because VectorFlow is more on the ingestion side, right? And I think at a certain point, once you have the information in the vector database, you need to be clever about how you retrieve it, right? So I think that's where like also certain things like re-ranking can come into play, where like okay, you have all these different concepts of a dog in the vector embedding, but it's like how do you actually turn that into like the right kind of overall view of the information to extract. Yeah.
Yeah. No, I think that's so. It kind of comes like into you mentioned writing custom code to parse PDFs, and like Unstructured is a really exciting company that's doing like one. I mean, I think there's a lot of cool parts to Unstructured, but one thing that Brian explained to me on the podcast was about doing like a visual document layout, and so you visually put the document, and you would say like annotate like this is an image caption. And so, because then, yeah, and then everything you do at importing time then is going to impact what you can do at query time. Because then if you want to have some, it could be a filtered search where you only want to search through image captions, or you want to have like a ranking kind of, like a ranking equation where you say like boost the results if it's a image caption. I don't know if image caption is the best example, but like that kind of thing.
Yeah, absolutely. I mean, Unstructured is a really cool tool. We're playing around with adding it to VectorFlow to help with certain things. For example, like how would you ask questions about like a pitch deck or a PowerPoint slide? And because maybe like that's portrayed as it's uploaded as a PDF, which our system accepts PDFs. But a lot of the information embedded in that might be visual or spatial. I think an interesting idea is like take the idea of an infographic, right? How, and let's say you have a textual system that you want to query, but you have an infographic in a PDF or a Word doc or something. How do you convert that into something that you can represent textually in the vector database, for example? And, are you storing multiple modals in the same index, or is there a way to do that transformation? I think this idea of having tags about images as well could be another interesting way around that. But ingestion problem in general, like there's so many different combinations of things that it's really exciting to think about how you can best represent those in a vectorized form and make the retrieval results ultimately better.
Yeah, I'm so excited about this conversation topic. Infographic, brilliant example. I haven't heard that before. And quick shout out to Unstructured with the shout out. I hate that word. I hate that I just said that. But like, quick highlight to Unstructured, who just did the processing tables visually and turning tables into searchable things. It's really inspiring work. And so I want to kind of talk about. I had this idea as you were talking, like with our whole conversation of metadata extraction. Maybe it makes sense to create a new class in Weaviate that only has like 50 objects in it, but they're really like symbolically annotated. And that's where you would store the kind of information needed for these symbolic SQL style queries. Like, if you have country music singers and like the ingestion engine is parsing through an entire Wikipedia page, maybe it just makes like one data object to put in this other class, which is like symbolic country music singers. I don't know. And then all the chunks go to this other class, which is like the vector class. And so you separate it into two kind of classes in sort of like a Weaviate native way of thinking. I'm sure all the vector databases do like some kind of abstraction between classes, something that sounds like that.
Yeah, absolutely. I mean, I think how the different information will ultimately get tied together is still an open question. That's what I was talking about. Like, what is going to be the solidified data access pattern? Um, Perhaps like it makes sense to have certain information in the vector database, and because the vector database, right, it's not the result that you get from the vector database. You're getting things that match your input query, right? But perhaps like in your re-ranking pipeline or something, you then go and you hit your SQL database to do certain kinds of searches that they're more optimized for. I think I think these kinds of questions the patterns and the best practices will become solidified over time. But I think it's an interesting idea to see like what else could you put into a vector database, And I'm curious, for example, like I brought up this idea of multimodal, like how well those things will play together, like an infographic in a PDF, for example, that has a lot of text. It's not something that candidly we've played around with yet, but it's certainly I think an exciting new frontier because if you think about like most data in like a corporate environment, it's probably going to be mixed.
Yeah, no, like I feel like with the world of vector databases, I feel like there's kind of the power in the HNSW implementation and then all the database kind of stuff around making that like CRUD compatible and scalable and all that kind of stuff. And then I see like these two layers with like the importing data into it and then kind of like the query engine, the query interface. And then of course there's like the language model, which is another like major like PowerPoint, I'd say, because of like the moat of trying to create another one. But like that kind of the query engine part is quite interesting because there's like the LLM frameworks market with like Llama Index, LangChain, Haystack, Gina, and others that I'm maybe forgetting off the top of my head, but like that they would do like this kind of like one thing, like one of my favorite abstractions in Llama Index is the query router, where the LLM takes the query and it says, is this a semantic search query, or is this an SQL query, or maybe it's like a knowledge graph query too. That's where I think these LLM frameworks will like always kind of sit in an interesting place, because they can like combine SQL with vector search with like these knowledge graph or like graph database technologies. And I think that's a really interesting kind of component to it. But I do think it's likely that, and I'm like, it's like, maybe I should like get to working on this right after we hang up the call. But like, I think it's quite likely that we can build some kind of interesting query router into Weaviate for this. It's like a little interesting, like how the design will work. But Weaviate has this module system where like, we interface our near text to do vector search, or our hybrid search, or hybrid, query API, as well as re-ranking. And so I think we can keep going up. Like, do we want to go so far up to have like chain of thought and like auto GPT style query engines directly into Weaviate? I'm really not sure, but I do think that kind of query router thing is going to be a pretty important part of it.
I think you and I actually might have talked about this the first time we had a discussion. I may have also talked about it with the head of research from Weaviate, that like this idea of query optimization, right? And it's like that's a big thing in traditional databases, where you have entire modules built into the system that can kind of translate things to optimize depending on what you want, whether it's like a smart way to index, or you're optimizing for speed or whatever. And in terms of the performance of the query, like as measured by the fidelity of the result, right? I think that's actually a really interesting frontier for vector databases. And can you put a query sort of optimizer in front of it? And like you were describing it as a router, but what I almost imagine is something that can kind of reword things, and whether that's like a machine learning model, like a large language model of some kind that's specialized to that task, or whether it's the exact approach, I think, is unknown. But this idea of like once you have enough data about how different queries perform, you could actually start to alter the wording to make them better, I think is actually a really exciting frontier. It's outside of the box of what we're doing at VectorFlow, but it's definitely something we've heard people ask for pretty consistently in the discussions. Is like, yeah, we're not exactly sure the best way to hit the vector database to get the best results. And it would be cool if you guys built that, because you probably have all the internal data to know like what actually does constitute like a good query versus a bad query for the same index.
Well, this is so much cool stuff in what you just said. I think like kind of, like the query formulation thing, maybe just come on that and then hit it with the big payload thing. I changed the conversation topic with this, but like, that kind of idea of you take, like, people are sending prompts. And so you don't want to just send the prompt as the search query most of the time. You'd want to like, extract like what is a search query particularly, send that to the vector database. And then that's kind of how it all gets combined with the prompt and the new search results. But here's kind of the thing that I think is like really exciting. So I'm stealing this term from Andy Pavlo, who's a professor of databases at Carnegie Mellon, which is self-driving databases. So it's about databases that kind of like optimize themselves, the indexes they build based on the queries that they're seeing coming in. So like, if you're like a payroll database, and you're seeing this particular kind of, let's say you have like 30 tables, you got like this crazy complicated payroll, and so you're seeing this particular kind of joining pattern being queried a lot, you would start to like build up an index for that join. And so I'm really curious, like this also comes into this other topic at Weaviate that we like a lot, called generative feedback loops, where generative feedback loops are like, you take some of your data, you put it into an LLM, and then you save the resulting generation. So so kind of marrying these ideas is like, you're seeing particular kinds of queries coming in, and then your LLM could kind of like transform your data in your database to better accommodate these queries. And I might be diving into much. Let me like get your temperature on the idea at a high level, and then we'll kind of go further into how this might work.
I mean, I think it's an interesting idea as long as you basically accept the premise that a vector database doesn't provide the same set of guarantees that a normal database does, right? Like, with SQL databases, you have like the ACID principles, like, you want to make sure that the data is always like the transactions guarantee the integrity of the data and certain things like that. I think if you're treating the vector database as a store to really provide some kind of system capabilities like around end user performance, rather than like we need this data for this system to kind of have its core operation, like to store it, to to back up what's happened and to be a
Mm.
record, but rather like this enables like the core flow. And you accept that those are different premises. I don't know if I'm describing it
Mm.
the most adequately, but I think you get what I'm saying. Then it's a really interesting idea because you can basically tweak things to give better results. And I think it's almost like the opposite approach of what I suggested, where rather than optimize the query, once you figure out what the access pattern is going to be, you can then kind of tweak it. Um, what you're almost describing to me sounds kind of like a recursive feedback loop along like, okay, we have our initial chunks, we put a bunch of stuff in them. Now we have this feedback loop built out and we see how people use this. Let's let's alter these chunks. Let's continue to evolve them. Where I see some complexity associated with this is it's my expectation that what's in the vector database is not going to be static. I think there's some scenarios where people will ingest stuff once, but I think one of the problems that we're seeing is more like you have to sync data, you have to ingest stuff. Like one of the things we're building into VectorFlow is like a dedupe mechanism. So
Mm.
the idea that you're not going to, add duplicate vectors when you have to update. And so, how would this idea of having a feedback loop that alters the core uh, embedding in the database play with the fact that you also need to like constantly refresh data in a production system?
Yeah, it sounds really exciting. I mean, I guess it's like maybe your queries tell you something about the data you didn't originally, that like maybe the queries are telling you just like to add this kind of filter, like look for this kind of thing, particularly because I'm seeing this feedback where they like these kind of answers, like kind of like that long tail versus the popularity kind of thing. And yeah, I don't know exactly, but I think really the key thing and how this ties into like how you think about how you import data is like just probably I guess it's there. There's definitely like levers of control here, like with the so kind of coming back to like the self-driving databases in more of an SQL sense is like you can build up certain index structures for different kind of properties that then speed up the latency of making those kind of queries. And vector search has a similar kind of analog with the HNSW graph, where if you know that you're always going to be doing this one kind of filtered search, you can like increase the connectivity of that kind of search. So the way that filtered search in HSW is implemented is you have like an allow list, and it's traversing the graph, and it's saying, are you on the allow list? Well, no. Okay, well, I'm still going to explore your neighbors, but you're not going to be in the results set. And so if you know that you're doing a particular kind of filtered search all the time, you could kind of connect those filters, and then that allow list will, the result list will be populated quicker, and so you'll have a faster latency. So I see that kind of angle to it, where you're just trying to speed it up by what queries you're having, so you're going to index in advance. But then there's maybe something to like the queries tell you something about the information that causes you to think, okay, I need to change the information that's in my chunks, or like something like that.
Yeah, I mean, no, it's definitely an interesting idea. I mean, I'm just kind of thinking out loud here that like, if you have the capacity to do it, like your organization, you can afford to have multiple different versions of the data stored, right? Like you could even think about having things in different actual graphs and some sort of proxy layer in front of the database that kind of
Hmm.
decides at runtime, like which index you want to hit. I'm just kind of trying to connect the dots with like, I know traditional databases have proxies that do a lot of interesting things. It's more, I think, on the performance side, like connection there, sharing and things like that. But like, could you combine this idea of like the kind of self-driving database with a proxy layer that provides the a smart interface
Mm.
um, to actually make the results as good as possible?
Yeah, no, that sounds really exciting to me, because you like coming back to the HNSW thing, like having two separate classes. One class is like this, optimized for filtered searches, and the other one is just the ordinary HNSW. And you have like these two classes, and you have this kind of proxy orchestrator that's saying, I'm not getting enough filtered searches anymore. Let me go ahead and destroy that because the memory overhead doesn't make it worthwhile anymore. And yeah, I think there's a lot to that. I think it's a pretty interesting kind of direction, and the reason I think it might be relevant to vector flow and managing imports is I think a lot about this kind of like the generative feedback loops. And this is Bob's idea, I'm just like just sharing it, but like this, like having like a REST API around the generative feedback loop that would so like one example is like when you're generating synthetic data from for your task or whatever, every like 10 you might want to like back up your database because you're paying for these LLM inferences. You want to save it if you potentially have it crash. But if I save it every 10, and now I have like the newest one after 100, it's like go ahead and delete those 90. That's kind of like the infrastructure management task I see is like, okay, I don't need these backups anymore, go ahead and delete them. It's kind of like a garbage collector for the data backups. So I could see that kind of thing being managed by an external service rather than Weaviate itself.
Yeah, that makes sense. I mean, I think in general, it's kind of like the difference between the vector store and sort of this whole vector ops lifecycle. And that's part of it, along with just, it goes into understanding when you want to refresh the data. And that's a big part of ingestion as well. And so I think the way that you see tooling built up around traditional databases, I expect you'll see tooling built up around vector databases to help people get the most out of those systems. I'm curious, kind of like, what are you guys sort of encountering on the sort of educational side of things? Because we're talking about all these capabilities that we see and how we could see stuff evolving. But
Mm-hmm.
one of the things I sort of notice in a lot of the discussions that I have is that people still need to really be introduced to the idea of like, what can you really do with a vector database, and why do you need to put it into your system architecture? So I'm curious, like, how do you see this becoming more approachable to like the general kind of community, the software engineering community as a whole?
Well, it may, hopefully not too redundant, but I do think that kind of the zero shot model, like what makes it more accessible is the zero shot models. Sorry, can I ask you one more question before we come into this topic? Is
Sure.
quickly, I just wanted to ask about the GPT cache idea, where you take LLM responses and then you cache them, and so now you take a new answer and a new question, and you would map it to its nearest. Like you take a new prompt, you map it to its nearest prompt that's already been answered, and then you give them that answer. And so so sorry to let me like so back
Yeah,
into
of
this
course.
conversation. Sorry if you don't. I just want to get this last one, and then and then I'd love to come into the topic of how do you evangelize vector databases. But like this, GPT Cache is like the LLM does some kind of response with your data, and then you save it. So it is like a generative feedback loop where you save it back in the database, but it's for the sake of question answering in the future. Yeah, have you seen this kind of GPT Cache thing? And like,
Yeah, we actually looked into it when we were first exploring like different ways to deal with some of these problems, because like you do part of getting the best performance out of the vector database is like probably to do some caching so that you don't have to hit it, right? Tons of traditional systems have caching of one sort or another. I think the trick is like to do smart caching in a way that's not
hmm,
really expensive or really burdensome in terms of the memory. Um, I think that's where actually this idea of like a zero shot LLM that is designed specifically to kind of do semantic caching could be really
hmm,
interesting, where it's like you don't actually have to hit chat GPT. Maybe you could have a model that's more parameter light, that could even run like on a much smaller device, like not on a GPU, that just enables that to be really efficient. Because it's not the problem, right, is it's not like a traditional cache where you can have like a key value store. You need to really be smart about
hmm.
how you decide to cache and what you decide to cache.
It's interesting that kind of key value store analog, because I know a lot of like researchers think of like deep learning is just like glorified hash tables, and you could think of embeddings as kind of like a key hash, and so it kind of relates to that idea. But I guess the thing about GPT Cache and how I'm seeing most people using it right now that I find to be interesting with this more like autonomous self-driving database kind of concept is like usually GPT Cache is triggered by a real person came and asked a real question, and this is the real answer that they liked. Therefore, in the future, let's use that answer again. Whereas imagining like an LLM that's just like, you know, prompting itself with your documents and creating more information, and like would you ever want to return that information that's created by like an LLM retrieves like two parts of your documentation and it says, I don't know, write a comparison of these two, or like think about how you might combine, like if you take like atomic APIs and it's like, how might you write a compositional API of these APIs, and it creates like new data, and would you want to then index that and maybe return that for a search?
So if I understand what you're saying, are you basically saying like you use the LLM to populate the cache, kind of, is like sort of
Yeah,
the
yeah,
idea? I mean,
yeah,
it's definitely an interesting idea. I mean, I think you'd have to like somehow have some human feedback in the system. That's something that,
yeah.
we actually, it's a topic we've kind of skipped in this podcast. Maybe in the next one we'll talk about it. It's like, where does human feedback come into the system? But it's certainly an interesting idea, and I think it goes well with the general theme of like, at some point, once these technologies mature, you'll be able to kind of use them for recursive sort of improvements where they can just make
Mm.
themselves better with some human guidance. And I think that the idea of applying that to a cache is definitely an interesting mechanism, as opposed to like, the more crude caching strategies that we have now, like least recently used, and, putting time limits
Mhm.
on the cache, and
Mm.
having maybe better ways to assess like what really needs to be stored.
Hmm. Yeah, I love this topic. It was such a fun conversation, and yeah, I think we have so many interesting topics about all that, and I think, yeah, I do like. I think this kind of external document manager outside of Weaviate could eat up a lot of functionally what this kind of stuff ends up looking like. But yeah, let's take the step back. I know this is like dreaming into the future. I just like I always like doing that. But this kind of topic of how do you evangelize these new technologies? I mean, maybe let me first ask you where your head's. Obviously, you're starting this new company, VectorFlow, and trying to get off the ground, get some content, get some users, and all that is maybe like, yeah, how do you see that in your focus, and how are you currently thinking about it?
Yeah, I mean, I think it's. I think for us, we're really trying to more understand the access patterns around vector databases right now, and that's why I was saying, like, we're still waiting to see how those mature. Like, what are the common? Like we talked about metadata. What are the common fields, or
Mm.
like what are the common data sources? What are the common formats? What are the main kind of issues that you're encountering with ingestion? Because I think VectorFlow is designed really to be sort of this, like, let's get to production quickly type technology. Um, but I think there's one of the things that we're seeing is a lot of people using LLMs that just don't really fully understand the power of semantic search and the wide variety of use cases, right? Like, people know about, to some extent, like this idea of ask questions of your data. But for example, a lot of people don't know that like you need to use semantic searches, for example, in facial recognition. Or like, I was actually thinking this morning about how like at
Mm.
SpaceX, they maybe could use it for inspecting rocket parts, right? Because like these rockets have, I think, I want to say, this is a number off the top of my head, but I want to say there's like 2 million parts in like a Falcon 9 rocket. And it's very precise. And like, what's the difference between a test part versus a flight part? Like, it's minute. And could a conventional model by itself, just doing inference, detect that? Or would you also want to do some kind of more complicated similarity search? I'm kind of going down a rabbit hole here, but it's like, people still don't
Mhm.
know about the broad applicability. So I do feel like there is some degree of education that we have to do as well, because we are a pipeline that is dependent on technologies like Weaviate. So people need to first know, like, well, what should I be using Weaviate for? It's like, oh, okay, I need that. Well, yeah. And also like, oh, that makes sense. And if I want to get stuff in easily and get to production quickly, like, oh, VectorFlow.
Yeah. Yeah, that inspect the rocket parts, that's one of the use cases I've seen with Weaviate that just always stuck in my brain. Is it was airline manuals, and like searching through a particular kind of configuration of that. It always motivates me to talk about this metadata thing, and grounds my thinking and chunking, just because of seeing what that kind of thing ends up looking like. But yeah, so exploring all the different use cases that can exist of vector search technology very broadly. I completely agree. I think like I don't think we have a good sense of what multimodal retrieval augmented generation is going to look like yet. Where I imagine it in the e-commerce case where I'm like, show me what I would look like with a white bucket hat or something like this, like where it retrieves the images of me, and it like fuses that with the image search of bucket hats, and it like combines these, like this kind of combination of like modalities in retrieval augmented systems. Yeah, the applications certainly are still growing. Yeah. Well, I would like to pitch you one more thing, kind of like future looking thing about what I think is going to heavily impact how you evangelize technologies broadly is the Gorilla large language models. So with the Gorilla large language models, what I would imagine a user doing is you tell me a little bit about your data scheme, like your data. Maybe Gorilla designs a schema for you, and then you say, okay, build me an ingestion flow from my Notion to Weaviate using VectorFlow. And Gorilla is an LLM specialized on the APIs that, like Weaviate and VectorFlow collectively build. And Gorilla does all the intermediate stuff. So like, writing all the Python code for doing this. Yeah. What do you think about that kind of idea?
I mean, it's definitely an interesting idea. I mean, I think like it'd be interesting to see how that would fit with VectorFlow, because our whole, like, one of our overarching design principles with VectorFlow is like to just try to limit system complexity. And it's definitely a challenge because there are a lot of things that you need to tweak. And so our idea is like minimizing how much code you have to write, having, just a simple API endpoint or a config file. And so I think if there's a way to even remove that complexity, it gets you to production faster. I think the other thing, like VectorFlow, is really useful for testing, right? We were talking about like the need for more kind of formalized testing strategies, and the idea that you probably need to really figure out which hyperparameters work best for your retrieval system. You need to test a lot of things in ingestion. So this idea of the Gorilla model just enabling you to go through that cycle really quickly, or even doing it for you, could be super, super cool. It could basically just remove a lot of like more grunty aspects of setting up these systems and figuring out exactly how well, like the best way to make them play nicely together, I think is a super interesting idea.
Yeah, because I think like with VectorFlow, you're going to create this documentation that shows you how to do the particular syntax, and then if you have a language model that I can just tell you like, roughly what I want to do, and it just translates it into the VectorFlow APIs. Now the learning curve for me, a new VectorFlow user, becomes a lot lower. I think for Weaviate, and it's a bit more it's pretty interesting because like for us, like users need to learn like the search APIs. So like you need to learn the syntax to like put two filters on your vector search query, and so that language of being like add these two filters and it generates the GraphQL, that excites me a ton. It's kind of like the text SQL stuff, but yeah. Because I feel like it just, when you're evangelizing your new technology, you have this like learning curve, like, learn my syntax, learn my new, my library kind of thing.
Yeah, definitely.
Yeah.
I think that's why we tried to stick with HTTP as the first way, like to
Mm.
sort of be an entry point into the system. Um, but there's a lot of different things to tweak. For example, like, a lot of traditional tools like allow you to pass in Python scripts to run specific transformations. And I think one of the things that we are exploring actively right now is like, what is the main flow, and
Mm.
where are the real barriers to entry in terms of getting things to production. We know that one of those is infrastructure, which is why we're building what we're building. But I think anything that reduces that friction, whether it's a large language model or just a well done integration between two systems, I think is ultimately going to allow people to extract a lot more end value from these systems.
Yeah. I agree 100%. Yeah. And I just think kind of thinking about the future of what these integrations are going to look like is pretty exciting. Like how, yeah, like you mentioned like HTTP and like networking protocols, and I guess it's almost like that. Like if language is the interface now between all software tools for integration, sort of like how, HTTP requests are the interface between like networking endpoints. And that's kind of how I see the future of that kind of part of it. But yeah, anyway, so yeah, I love talking about the Gorilla language models because I just think it's a pretty cool topic. But anyways, David, thank you so much for joining the Weaviate podcast. I think I really liked our kind of initial tour of like jointly understanding the end to end of importing from, connecting these different data sources, the kind of metadata, chunking, visual document parsing, all those, that kind of topics. And then how do you vectorize? And then I guess the last networking to get it into the database. It's such an exciting space. And, thanks for the conversation around the self-driving databases, generative feedback loop. I had so much fun discussing that. And, thank you so much. Good luck with everything.
Yeah, thank you so much for your time. Super, super cool to do a discussion like this where you're just, you're in certain ways, getting a very specific exposure that I love to hear the new ideas that come up, and then we can chew on those and think about how we could put them into our system. So it's a lot of fun. Super excited to see what happens in the space.